Section 1. A window to the poles. Understanding polar zenithal projection. Imagine looking straight down at a spinning globe, your gaze fixed on the North Pole. The polar zenithal projection captures this unique perspective, transforming the curved surface of the Earth into a flat, circular map. This projection centers on either the North or South Pole, making it ideal for representing polar regions with minimal distortion. Unlike other map projections that stretch and squeeze the Earth's surface, the polar zenithal projection maintains accurate distances and directions from the central point. Imagine a series of concentric circles emanating from the pole, representing lines of latitude. These circles intersect with straight lines radiating from the pole, representing lines of longitude. This unique perspective offers a valuable tool for understanding polar geography, particularly in fields like navigation, meteorology, and aviation. It provides a clear and accurate representation of the polar regions, where traditional maps struggle to capture the true relationships between land masses and distances. Section 2. Importance and applications mapping the Arctic and Antarctic. The polar zenithal projection finds its greatest utility in mapping the Arctic and Antarctic regions. These icy landscapes, often shrouded in darkness and extreme weather, pose unique challenges for cartographers. Traditional map projections distort the shapes and sizes of land masses at high latitudes, making it difficult to accurately represent the polar regions. The polar zenithal projection overcomes these challenges by preserving the relative sizes and shapes of land masses near the poles. This accuracy is crucial for a variety of applications, from charting shipping routes through icy waters to tracking the movement of icebergs and monitoring changes in sea ice extent. Beyond its practical applications, the polar zenithal projection also serves as a valuable tool for scientific research. Scientists studying climate change, for example, rely on this projection to track changes in ice cover, ocean currents, and atmospheric patterns in the polar regions. Its ability to accurately represent these remote and dynamic environments makes it an indispensable tool for understanding our planet's changing climate. Section 3. Drawing the projection, a step-by-step guide. Drawing a polar zenithal projection might seem daunting, but it's a surprisingly simple process. You'll need a compass, a ruler, a protractor, and a pencil. Let's begin. First, draw a circle using your compass. It can be any size. This circle represents the Earth. Next, carefully mark the exact center of the circle. This point represents the North or South Pole, depending on which hemisphere you're mapping. Then, using your ruler, draw a straight line through the center of the circle, extending to both edges. This line represents the equator. Now, using your protractor, mark points along the circumference of the circle at 15-degree intervals, starting from the equator. These points represent lines of longitude. Finally, using your ruler, draw straight lines from the center of the circle through each of the marked points on the circumference. These lines represent lines of longitude. Congratulations, you've just drawn a basic polar zenithal projection. You can now add land masses, label continents and oceans, and use your projection to explore the polar regions in greater detail. Section 4. Interpretation and applications. Navigating the top of the world. Interpreting a polar zenithal projection is like reading a compass rose from the center outward. Distances are true along lines radiating from the pole, while distortions increase as you move away from the center. This makes the projection ideal for plotting great circle routes, the shortest distance between 2 points on a sphere. Imagine planning a flight from New York City to Tokyo. On a traditional map, the shortest route appears to curve northward over the Atlantic Ocean. However, a polar zenithal projection reveals that the most efficient path actually passes over the Arctic, significantly reducing flight time and fuel consumption. This ability to visualize great circle routes makes the polar zenithal projection an invaluable tool for long-distance navigation, particularly in aviation and shipping. It allows navigators to plot the most efficient courses, saving time, fuel, and resources. Furthermore, the projection's accuracy in representing distances and directions near the poles makes it ideal for mapping and navigating the Arctic and Antarctic regions, where traditional maps often fall short.